To Intro to Big Data and Hadoop course. I'm going to take you through the prerequisites for this course and an introduction about what I have in this course. So before we delve into more of big data stuff, let's look at some of the things that this field is comprised of. Before we start extensively big data, I expect you to know just a little about what is MySQL, Ubuntu, Java, and Hadoop. So MySQL is an open source language based out of SQL. It's managed by Oracle, but it's open source. And SQL stands for Structured Query Language. Ubuntu is a Linux, which is a kind of operating system. Java is a programming language in which we build big softwares, and it's very fast. Ubuntu is operating system which allows us to install Java, and Hadoop is written in Java, so Java can be used to make programming language. The recording tool that I'm using, for example, here is made in Java. The Chrome and Firefox, the browsers that we use, are made in Java. All of these four technologies are open source, although they are managed by different companies. MySQL is managed by Oracle. Ubuntu got a big funding from Google. Java is managed by Oracle, Scala is managed by Apache, and Hadoop is managed by Apache. We are going to implement all of our code on VirtualBox, which is a hardware virtualization, and it is managed by Oracle, or they have made it open source for us. We'll see how to install Hadoop on Ubuntu and understand the steps and the errors that we might encounter. Once we install Ubuntu on VirtualBox, we will install Hadoop on that. Hadoop comprises of its file system, its operating system, and Hive, which is a structured way to query data. So the first part of this course would be to understand Ubuntu, understand some Ubuntu commands. Then we would look at the architecture of Hadoop, which is like a diagram of Hadoop, or what is Hadoop comprised of, how to overview the whole architecture and nitty-gritties of how Hadoop works in terms of what is the file system, what is the operating system, and what are the applications. We'll understand NameNode, DataNode, Yarn, and other aspects of Hadoop infrastructure. I generally have small quiz that I follow once I do every session. So the first step would be to install Hadoop. Once we install Hadoop, we'll have the file system ready, so we would look at file system commands just after installing. After that, we would run Mapreduce and understand Mapreduce paradigm by using two examples in Java. We are going to look at two installations of Hadoop, 2.7 and 3, and we are going to look at two aspects of installation where we'll have just one user who will be running Hadoop, and the other will have one user, Hadoop user or HD user, which would be using Hadoop. So like two users and using Hadoop user to run Hadoop versus just one user, which is the main user who would be running Hadoop. And two versions of Hadoop, 2.7 and 3. 3 is the latest version, and it came like 6 months ago from this point, which is like Feb 2019. Then we would do 20 Hadoop file system commands and set up Java to run the two Mapreduce that we want to run. Now, in terms of data, we have three types of data: structured, semi-structured, and unstructured. SQL is the structured data, so we would see how to use relational database and understand the difference between SQL and NoSQL, and understand the NoSQL and SQL counterparts in Hadoop. We'll look at Pig, which is a scripting language to run Mapreduce on structured and semi-structured data. Now, a lot of data is structured data exists in SQL, so we have to move back and forth the data from SQL to Hive, or relational database world, to Hadoop world, which we would do by Sqoop. Sqoop we could also run on Cloudera, which I'm going to show you, and we'll understand what is the Cloudera distribution. Then we would look at Pig, Impala, and we would look at an introduction of NoSQL database, which is MongoDB outside Hadoop world, and Hbase, which is on top of the Hadoop. Then we would look at creating database in SQL, running group by and joins, and moving those things to Hive. In Hive, we would look at performance aspects like Hive partition and bucketing, internal table and external table. Now, Hive is a way to store data, so there are some things that you need to keep in mind, like you cannot delete any rows in Hive because it's not like SQL where you can delete a row and everything gets adjusted. That data is stored in a flat file. So we have to manage Hive and understand the internal and the external table. After that, we would look at Spark and Scala and Python. Spark is an in-memory database and it can do calculation very fast. It's 10 times faster than the MapReduce that we would run otherwise. So we would look at Spark installation. We will look at Scala as a language. We would also look at Hadoop streaming Python, which is how to run Python to run MapReduce using Hadoop streaming. And then we would look at how to use PySpark and how to create RDDs. We would look at running Spark shell and importing data from CSV and configuring a Spark job. Then we would have a project where we would take CSV on the Hadoop file system and move it to Hive using Hive import, and then run SQL-like queries. We'll do the same and import the same in Spark in an RDD and run the queries. We would also see how to install MySQL and Workbench and use Sqoop to move it to Hadoop file system. And we would see how to use Jupyter, Anaconda and Spark Context to run count on completely unstructured data like news data. We'd also understand the different delimiters like comma, space, tab, pipe, double colon, and how to use them in Spark Context and Spark Shell. At the end, we would learn more about Kafka, which is message broadcasting and flow. And we would look at Cloudera, and Cloudera is a private company, a for-profit company that's distributing Hadoop in a nice way, and it has some certification which we would look at. And we would look at the implementation on AWS, DigitalOcean, and then we'll look at commissioning, decommissioning, container configuration, and cluster debugging. This is the certification of Cloudera Developer Certification, which I particularly like, because in terms of other certification it's very exciting, less memory based, and if you know MySQL, if you know SQL, then this becomes very easy, and it has the exact thing that is demand in the market right now, like Hive and Spark. The only thing outside this which is high in demand, which I would like talk about, would be Kafka or some messaging system. So Kafka, Hive, Spark is like the three trio that is used extensively right now in the big data world. Now in the data ingest part, we would look at how to move data from MySQL database to Hadoop file system using Sqoop, and vice versa. We will look at different delimiters. We will look at ingesting real-time data or near real-time data into Hadoop file system, processing data as it is stored onto the cluster, and load it into an output in and out from HDFS using Hadoop file system command. The transform, stage and store is more about the Spark world. Convert data set in a given format into new data values or new data format and write them on the Hadoop file system. RDD stands for resilient distribute data set. It is a Spark data type, and we would see how to get data from Hadoop file system and convert it into an RDD and convert it back into Hadoop file system. Reading and writing files in variety of file formats and performing standard extract, transform, load on data. Then we would look at data analysis using Spark SQL to interact with metastore programmatically in our application and generate report using queries against store data. Then we'll look at using metastore table as an input source or an output sink for Spark application, understanding fundamentals of querying data sets in Spark, filter data using Spark, write queries that calculate aggregate statistics using native Spark shell or using data frames. We'll also look at joining disparate data set using Spark, understand left join, right join in Spark context, and produce rank or sorted data. So coming back to what I just talked about in my first slide, what is Ubuntu, what is Java? Is Hadoop a database? Can I install Hadoop and practice at my computer? So Ubuntu is an open source operating system just like Windows or Mac. Java is a language to build big programs like browsers, Hadoop, or some very big programs. Hadoop is not a database, but it's an architecture to store a lot of data from different sources, structured, unstructured, semi-structured, and store different kind of data, streaming data or dormant data, and perform in-memory calculation or do a lot of stuff. Hadoop has its own file system and operating system, an application that run on top of that. Can I install Hadoop and practice at my system? The answer is yes. So this was part 1 about the prerequisite and intro to the topics that I'm going to teach.